Well, pre-calculus classes, once again, good morning, good afternoon, or good evening. We are going to get started into section 4.7 now, dealing with inverse trig functions. And, if you think about the first half of chapter 4, if we were looking for an angle in a right triangle, how did we find that value if we had two of the sides? Well, we used the inverse of sine, cosine, or tangent. Now, one of the things you do need to be aware of is it is very possible you're going to see sine inverse, possibly written in another way, which is either the sine inverse of x or the arc sine of x. Again, what that means, the arc sine of x is simply the angle whose sine is x. The inverse of x is the angle whose sine is x. So again, arc sine, inverse sine, basically, those are interchangeable terms. Now, referring back to some things we talked about in Chapter 1, one of the things that you'll see is a lot of that algebra review we did first semester was to, go back over those key topics so that way we can apply them to the trigonometry. So from 1.8, for a function to have an inverse, it must pass the horizontal line test. To be a function, it has to pass the vertical line test. To have an inverse, though, it has to have a horizontal line test. Well, if you think about our sine waves or our cosine waves or tangent, well, none of those would pass a horizontal line test. So we have to restrict the domains. And, one of the things, too, like when I was graphing some of those other three trig functions, sometimes when I set up my tables, I did those in kind of an odd way. Well, we're going to talk about that now. So, all right. For a sine wave, well, when we graph sine, 0 max, 0 minimum, 0. Now, again, as we said, the problem with a sine wave, it's not going to have an inverse. It does not pass the horizontal line test. It doesn't pass it here, doesn't pass it here. So if we're going to create a function that also has an inverse, we can only use a portion of the graph. Now, the other issue is we want a continuous portion. I can't use the upper half. That's not going to be an inverse. I can't use the lower half. Not going to be an inverse. So what we actually have to do is come back and use this portion. So negative pi over 2, negative 1. 0, 0, pi over 2, and 1. So what we are going to do here is, and I'm even going to actually fill in, well, we can fill in with some of the intermediate values down here. But what we're going to actually do is we're going to restrict from negative pi over 2 to pi over 2. I pass a horizontal line test from just this portion. Basically, it'd be like I'm only using this part of the graph. I also have all of the y values that we need. We include the entire range from negative 1 to 1. So, when we graph the inverse, you switch x and y. And, again, what we can even do is, since we're working with sine, we can use pi over 6.5. And we can also use negative pi over 6 and negative 1/2. When we are introducing these new functions, I know sometimes it's always helpful if you see, so here's 1, negative 1, 1/2, negative a half. So notice now, along the x-axis, I'm using the simple numeric values. Along the y-axis is where we'll go pi over 2, negative pi over 2, and then the pi over 6 and negative pi over 6. Again, those are closer to 0 than these are. So negative 1, negative pi over 2 is here. Negative a half, negative pi over 6 is here. 0, 0. So you can see it curves there. I'm not getting great curvature on this, but so it curves in and like that. So your domain goes from negative 1 to 1. Your range goes from negative pi over 2 to positive pi over 2. I'll be honest, we will not ever ask you to graph these. More importantly, just that you'll be able to recognize the graph. I mean, the nice thing about inverse sine, it does go through the origin. So your domain's negative 1 to 1, range is negative pi over 2 to positive pi over 2. All right, if we do the same thing for cosine, well, again, 2 pi over 2 and 3 pi over 2. 1, negative 1, so max 0, minimum 0, max. Now, again, with a cosine wave, it would not pass the horizontal line test in full. We do have to restrict it down. Now, unlike sine, we don't have to come over here into the negatives. If we restrict from 0 to pi, you still pass a horizontal line test. You also have both positive and negative y values, because that's the key. That's why we did have to, for the sine wave, go into the negative, because we need both positive and negative values, and we want those consecutive. I mean, I guess in theory you could use pi over 2 to 3 pi over 2, but we do prefer to include 0 in that function if we can. Notice, we're still including 0 here. So, I have points at 0, 1, pi over 2, 0, pi, negative 1. So, 1, 0, 0 pi over 2, negative 1 pi. I am going to come back and fill in with my in-between values as well. You know, again, the in-between value for cosine, we'll use pi over 3. Which, when you go pi over 2 and negative pi over 2, pi over 3 is closer there. And keeping on over to 2 pi over 3, negative a half. Which, when you graph it, and actually I realize now, we don't need below. I got kind of in the habit of graphing like the other one. So here is my 2 pi over 3. So 1, 0 is here. 1/2 pi over 3 is there. 0 pi over 2. Negative a half. 2 pi over 3. And negative 1 pi is there. So, all right, again, not a great, these are the, probably of all the graphs we do, these are the ones I struggle with getting the curvature in there. Again, you will not be asked to graph these. The key thing is that you are aware of what the values are. Your domain, negative 1 to 1. Same as sine inverse. Key difference is your range. The range goes from 0 to pi. And then the last one that we are going to need the inverse of is tangent. Well, for tangent, negative pi over 2, and when we grab a unit circle here, negative pi over 2, y over x is undefined. At negative pi over 4, negative 1. At 0, 0 over 1 is 0. I know I graphed it before I actually listed it in the table. Pi over 4 is 1, y over x. And then pi over 2, 1 over 0 is also undefined. So, now, for this one, I'm not even going to graph any more of the tangent wave. And the reason, if I graphed another one of these, I mean, I guess I could put, pi here and say, okay, well, we're going to have another one of these. Well, you can already see, not going to pass the horizontal line test. I'm not going to go into real detail there. So what we end up, again, having to do is we restrict it from negative pi over 2 to pi over 2. Again, we always want to include 0 in that, interval. And it also allows us to have all of the y values that we need. All right, so inverse tangent. Now we're just going to flip all of these around. Well, when we flip these around, something a little different is going to happen. If x is undefined, instead of having vertical asymptotes, you are now going to have horizontal asymptotes. Now notice, your maximum y is pi over 2, your minimum y is negative pi over 2, and then we do need x values from negative 1 to 1. And then pi over 4 and negative pi over 4. So at pi over 2, we have a horizontal asymptote. At negative pi over 2, we have a horizontal asymptote. At negative 1, negative pi over 4. At 0, 0, 1, pi over 4. And so then we come in and have a curve that goes like this. So, biggest difference here, again, like I said, you now have your horizontal asymptotes. Domain and range are the two things that we need. I know these didn't get added on the printout, but your domain goes from negative to positive infinity. Your range goes from negative pi over 2 to pi over 2, except the key difference is parentheses. So, unlike the other two that had brackets for the range, these do not actually get to those asymptotes. So, we always go over the 3 inverse graphs. You will not be asked to graph those. You will be asked to be able to use these 3 functions. So, if we now come in and ask you for the arcsine of negative 1/2, well, here is how these all work. I'm going to get so here is domain and range for our sine inverse. And then if we use the unit circle, where does sine equal negative a half? Well, there's two places. At either 11 pi over 6 or 7 pi over 6. Now here's the problem. Neither of those are in between negative pi over 2 and pi over 2. 7 pi over 6 is there, 11 pi over 6 is here. So what we have to do is, instead of taking the longer path to get there, take the shortcut, negative pi over 6. Because we are restricted to using the right half of the circle going either counterclockwise to pi over 2 or counterclockwise to negative pi over 2. Sine inverse of radical 3 over 2. Well, there's two places, again, where sine's radical 3 over 2. We're only worried, though, about the right half of the circle. And that is at pi over 3, which is in between these. And then one last one of these, sine inverse of 2. Well, where on the circle does sine equal 2? Well, kind of a trick question because the maximum y value is 1. So this one is undefined. All right, moving on to cosine. Again, I'm going to range is now 0 to pi. Well, what that means when you're looking at the circle. Inverse cosine, you're using the top half. So where does cosine equal radical 2 over 2? Now we're looking for x values either at pi over 4 or technically 7 pi over 4. But again, top half of the circle is just pi over 4. Where does cosine or arc cosine negative 1, where is cosine negative 1? Only place is pi. When you have those quadrantal values, meaning on the axes, there is only one option. And then a couple of these with tangent. Let me grab domain and range as well for tangent. So again, tangent, much like sine, uses the right half of the circle. It has to go from 0 to pi over 2 or down from 0 to negative pi over 2 or clockwise, not necessarily down. So where does tangent equal 0? Tangent is y over x. The only place on the right half of the circle is at 0. And then where arctangent negative 1, well, where does y over x equal negative 1? There's two places, either at 3 pi over 4 or 7 pi over 4. But again, do not use the long route. Take the shortcut, negative pi over 4. That's one of the big issues that usually makes this section the most confusing is, we are making you work in a clockwise direction at least some of the time, especially with inverse sine or inverse tangent, arc sine or arc tangent. As far as your calculator goes, well, if you take inverse tangent of, you either get negative 1.453, or if I go back and change it to degrees, negative 83.25 degrees. So it gives you an answer between 90 and negative 90. If I take arc sine, I either get 14.16 degrees, or again, if we .247 radians, and I'll even come back up there. Now, arc cosine of 1.2 is not possible. And again, the reason on your unit circle, the maximum value for cosine, just like sine, is 1. Obviously, don't even need to do the conversion to the other mode for this, but that completes the first half of 4.7.